Will Robinson here from Robinson's Auto. Welcome back, guys. Today in the shop we have this 2005 Ford Freestyle. It's got the 3.0 V6 and it came in with a pretty good misfire the other day. We went in, we did the repairs. I did bring you guys along with me, but I was trying to be more interactive and using two different cameras, and the audio got totally messed up. So in a ditch attempt, I'm going back and trying to make a different type of interactive video with you guys to show you how I was able to determine what cylinder was misfiring, even though all the codes were cleared. So we had a P1000, which means either codes were cleared or the battery had died or been disconnected. So we didn't have any data to go off of like that, but we did have that nagging misfire, that fish bite. Not so bad at idle, but as soon as you put it in gear and started driving under a load, you really felt it. So what I'm gonna do, since that misfire was on cylinder number 1, I'd hate to go back in there and recreate the same exact scenario, because that would require me to pull the intake manifold off just to gain access to cylinder number 1. But I want to show you how I went about finding the misfiring cylinder and some of the steps I took to make sure for certain that our process data was correct before we went through all that work to gain access to that cylinder. So without further ado, let me take you in there. Tammy, can you start it up for us? As you'll notice, when it's cold, the vehicle's been sitting for a little bit. The misfire isn't so bad. As it warms up, you'll start getting that fish bite. Sometimes it'll get worse, sometimes it'll get better. But when you put it in gear under a load, it really stands out. Put it in drive. Step on the gas a little bit, power braking. Just a little more. A little more. Alright, that's good. A little more. I'm hoping you guys were able to pick up on that misfire and how it got worse once we put it under the load. This scan tool has some things that we could use under the powertrain to help further our diagnostics. In addition, if you have some mode 6 data that you have access to in a generic OBD, you can go in there and look at your misfire counters as well. I have this, so I'm going to demonstrate it, but if you don't have this, the next step that I'm going to show you using an oscilloscope to determine what cylinder is what can also help guide you. We could do a power balance, we could do a relative compression check, we could determine if it's mechanical or not. So let's see what, you have the key on, Tammy?
Yeah.
Turn the key on, please. Let's do a relative compression check. This one we had charging prior to starting up the camera. Next we're going to fully depress the accelerator pedal to the floor, wide open throttle, and hold. Push the pedal to the floor, Tammy. Now I need you to crank it. I'll tell you when to stop. Good. You can do the same thing using current with the amp clamp with the oscilloscope, and we can demonstrate that sometime if you would like to see that. So it passed the relative compression check. So it's saying that mechanically the vehicle seems like everything is contributing, and we have 0% loss on any cylinders. Okay, so we could go in now. And what I'd like to do next is a power balance test. Pretty much this is a misfire counter. Ford puts it out in a graph form and it'll show you what cylinder has the misfire. Placing transmission in gear and maintaining steady load may help identify a misfire. That's what we were doing before when I was trying to demonstrate it for you. Start it up. So right there, you can see the cylinder that's dropping out is cylinder number 4. The rest of the cylinders look okay. We don't even have to place it in drive. You can do it to see if it gets a little worse, but it's almost a dead miss at this point. Want to put it in drive, Tammy? Oh yeah, it just gets worse. So it's pretty obvious that it's doing a good job because we know that we moved everything to cylinder number 4. However, when this came in, it was showing cylinder number 1, and I didn't place it there. It came in this way, and I didn't know if I could trust the scan data. 90% of the times, it could be 100% accurate, but there's always that small percentage when it could be wrong. And for you to be misled on a job this in depth of pulling the intake and stuff off can really ruin your day, to say the least. Put it in park, Tammy. Shut it off. Okay, so this is pretty obvious that our misfire has now moved to cylinder number 4. It's what you've seen from the process data. And remember, if you have mode 6, you can go in there, look at your misfire counts, and try to determine a route to go from there. But this one isn't so easy. Well, cylinder 4 is nice and easy to get to, but when it came in, it was cylinder number 1 underneath the intake manifold. So I really couldn't get back there without taking the intake manifold off. So I wanted to be 100% certain that I was going in the right direction. It had the classic symptom of ignition, misfire. Ran fine, put it under the load, and it started getting that fish bite. So my gut was telling me it was ignition, but I wanted to be certain that I was going after the right cylinder. And I wanted to verify that with an alternative method. So what I'd like to do next is pull out an oscilloscope. You guys see me use the T-Book Mini in the past, and I'm going to be using the same one again today. Some of you guys have mentioned seeing this hand tech in the background. Maybe one day I'll demonstrate it. It's not my favorite scope. It does the trick. It has its place. But I would love to get a Pico scope. So if you're watching Pico, someone. But the T-Book Mini has been holding me off until the day comes that I do invest into the Pico scope, which I am saving for. It's on my wish list, and hopefully one day we can make that happen. So I'm going to demonstrate the T-Book Mini once again. I want to demonstrate this because this is a fuse buddy, and this is my first approach. I want to get to something easy, so I'll demonstrate that as we go. We're going to need a 20-to-1 attenuator. Look at that, still set up from when I used it last. I got to clean this stuff up. But this is going to be for the primary voltage. And we'll need a low amp clamp. In order to use the oscilloscope, we got to know where to hook it up, right? So I actually have some schematics pulled up. Let me drag them over here for you. And where I got the schematics for today's video was from BBB Industries. This is a very helpful resource. You can look up some TSBs, wiring diagrams, and I was turned on to this website through Ivan from Pine Hollow Auto Diagnostics. He mentioned it in a few of his videos, and that's where I learned about this. So as you can see, 2005 Ford Freestyle. Went to engine, went to subsystems, and I went to ignition. It gave me one schematic, and I actually saved this schematic to the desktop. We'll get a closer view. We'll zoom in a little bit. I'm hoping this is showing up on the video okay. But this is the first initial schematic that we brought up. And if you follow everything down, you'll see we have the ignition coils, 1, 2, 3, 4, 5, and 6. Everything's showing here, in addition to a ignition transformer capacitor. It says it's there to minimize radio interference caused by ignition coils. Okay, so that might add a little bit of something or another to the circuit, not certain. So what I thought was like, oh wow, everything looks like it's just on the ignition coils. We should get a nice clean signal from fuse F141 15 amp located battery junction box, BJB. Okay, we know that because 361A, if you look down here, 361A, pretty much sit that on top if there was enough room, and that would be your flow. But yeah, you would think that that fuse 41 from the schematic is the only thing feeding this circuit, or this is the only thing on that circuit. But you'll see otherwise once we go to the fuse box, and I'll show you what I found. The junction box nearest the battery. Then I located fuse 41 15 amp, which is right here. And I put it into my fuse buddy. Okay, now we've made a nice little circuit, pretty much doing the same thing, but we put this little loop here. Okay. So now that we had a place to put our amp clamp, we moved it a little closer and we started preparing ourselves. Now this oscilloscope isn't going to have any presets on it, and it's kind of one of the things I like about it because it forces you to learn how to use it. And once you put them in there, you can save your own presets. But it is what it is. I make the best of it because it's what I got. And I'll bring it in here closer and show you what we got going on. Because this is just initially the way I had it set up. So I'm just going to leave the scale set up the way I got them. Later we're going to add another channel, and that's going to come off of number 1. And that will be what we use for a reference to trigger off of the primary voltage. We could pick any coil. So to leave it set up the way I got it, I'm going to put this on channel number 2. As you see out the top, which would be that blue trace. Okay. Then we'll turn our amp clamp on. And we got this set to the 10 millivolts / 10 milliamps. And then we're going to 0 it. Push that button like so. We're going to install our amp clamp. Channel number 2, we have set up DC current times 10. I have a low pass filter on there. We'll leave that on full for now. We'll put the filter on later if we need it. 20 milliseconds, set at 2 amps per division. So each block is going to equal 2 amps. Okay, start it up. Well, the first thing I see right off the bat is that our current signals are upside down. So we can invert them in here, or we can simply flip our amp clamp around. Okay, and once I seen this, I'm like, wow, that's pretty noisy. There's a lot going on in that circuit. We could zoom in a little bit. I don't have a trigger set. It's going to be hard to really set a trigger on channel 2 because we have so many similar we can make it a little better. Not very much. But a very noisy signal here, so you can stop it. for a second, Tammy? I want to show you, we can zoom in, but Ford uses a multi-strike ignition on this vehicle. But you can see all these little amp ramps where they fall right on our peaks. So we want to try to get that a little cleaner. That signal is just a little too dirty. This vehicle really shows the misfire when you put it in gear, and I just want to see if we see something really stand out when we do that. Hold your foot on the brake and put it in drive. See, I think because the signal's so noisy, we're not really picking up the fine detail too good. So the signal's just too dirty. So it was apparent that there's more on this circuit than what initially meets the eye. So let's go back over and I'll show you the second wiring diagram that we found. But this time I went to electrical distribution, then subsystems, power distribution, and it says there's one here. And we came down and I scrolled through all these. Long story short, you get down here to the bottom. But you come up top and you see fuse F1 41 15 amp. That's the same one that we have the fuse buddy in. But now you look down and you can see that it's feeding the mass airflow sensor. It's also feeding the powertrain control module, the PCM. All 6 coils. The same ignition capacitor, and also all 6 fuel injectors. And there may even be more. But I do see that there's a branch here for the coils and the injectors. And most likely that's all that's on that line. But there may be more, we just don't know. But there's only one way to tell. So I've seen that we have C31, that's a connector, or 134, I'm sorry. C134. C is in Charlie, 134. So I looked up a connector view and I located where connector 134 is located. What my hopes were there is to get rid of everything else up here and see if we get a nice clean signal, or a cleaner signal, something we could work with down near C134, since it's easy to get to. We determined that C134 is located up near the radiator support, right on the front side of the engine. Pretty much clips into the shroud for the fan, and it's this big black bolt connector here. And we found a red conductor, so we're going to wrap our clamp around there. We can leave the fuse buddy in place. So we're going to start this back up. Okay, Tammy, I'm going to leave the time base at 20 milliseconds, 2 amps per division. Nothing's changed here. Can you start it for us, please? Upside down again. Okay, so right away I see that there's a much cleaner signal. Oh yeah, I can zoom in a little bit. You know, we don't have a good trigger point here, so it's looking really sloppy. But we have a much more defined pattern here. And 20 milliseconds, I see these 2 events that are really standing out. We should have 5 cylinders between them. 1, 2, 3, 4, 5. Okay, so those are the same cylinders, both of those events. That's exactly what the Ford IDS is picking up on. But how do we know what cylinder that is? So we know that we definitely have something going on, but now we got to figure out what cylinder that is. take a closer look at that. Tammy, turn it off for a second, please. Just gonna play for a little bit. Yeah. What's going on there, guys? Now that's the one that's acting up. Let's look at a known good right next to it. Right? You see nice oscillation. Okay. Nice defined shutoffs. That zoomed pretty far in. And oh, I think it was down here, right? Yeah, so let's zoom in on this one a little bit more. You can see I have a nice defined shutoff, but then I have, it's very unstable on that base, right? Very unstable. What is that? And why are we seeing that on the primary current? Let's just put this back to 20 milliseconds. Okay. Now we're back on the same waveform as we were before. So I didn't change nothing. 20 milliseconds, 2 amps per division. However, now we're going to add one more channel. We know cylinder number 4 is where our problem lies. I could back probe cylinder number 4. We could also look at the primary voltage for cylinder number 4. But for now, I'm going to demonstrate how I found the cylinder when it was in the back and I couldn't get to it, the back probe. There's a right conductor that all these have in common, and that's the power feeds, because that's where we have our current. That's where we're reading our current ramp from. So now we want to read the voltage. So if I take and I back probe it on the red side, I'm not sure if we're going to really see much activity on that side. We're going to just see the battery voltage staying constant. You'll probably see some activity, but where you'll really see it is on the ground side. So on the control side of the circuit, you'll see it turn on and off. Now it doesn't matter if you're taking an amp reading, you can put it on either one of those wires. But to do this next test, we want to back probe the control side, what we would call the ground. So, like I said, they'll all have the same color red wire, but there'll be a different color wire. On this one, it looks like it's an orange and yellow, and this is coil number 6. Known good. Every cylinder except for number 4 has brand new plugs and coils. All right, so the back probe, you want to keep the probe tight to the wire, and then you have your weather packing. You want to try to get in between that packing and go in just like that. You don't want to pierce the wire, and you don't want to tear up the packing either. And you'll feel it when it hits. And then you just stop there. You don't have to go shoving it any further. Remember, channel number 1 we had set up previously, and I'll go over those settings with you as well. But we'll be using a 20-to-1 attenuator. The reason for this is because there's a potential of a higher voltage than this may be capable of handling on the primary side of the circuit. So it could exceed potentially 400 volts, and that wouldn't be good. Here, green lead. Put it here. I know I'm not using the corresponding colors. I probably should be for a demonstration, but they all work pretty much the same. Now I'm going to find a good ground. Put it right over on the battery, and that should be good. Everything's still the same as we left it. I'm just going to take and move that up a little bit, because now we're going to introduce channel number 1. So we're going to go to channel number 1. We are on. I have that set at 40 volts per division. I do have a low pass filter turned on. We can turn it off for a little bit. See how it looks on full. DC, volts times 20. Okay, so let me do a quick save of this. Okay, so that's our before with just the current reading. Now we're gonna, you know what? I want to take a picture as well. Let's turn this on. Okay, now we have a fresh plate. And Tammy, can you start the engine, please? Okay, see how everything's just bouncing around? That's because we don't have a good trigger. So now that this only has one event, that's going to work really good as a trigger. So what I want to do is bring up my triggers here, and then my source, channel number 1. Okay? Then on this mixie, you see where it says level? That's how you control that trigger. So you push that, and it brings up this little slider with that yellow arrow. And then we simply move that. See if I get it out of the screen, everything just starts rolling again. If I grab it and I bring it down, this is the one we're trying to trigger. This one here has a lot of noise in it because of that misfire. So we know this one here is cylinder number 6. So if I add that filter like I had in there before, you see it took out that other noise, and all we're seeing is cylinder number 6. And I can move this up a little bit just to give you a clearer picture. Might move this trigger down a little bit, and as you can see, it's nice and stable now. We can take and we could stop it. We'll pause it for a moment, do a little quick save, and I also would like to take a selfie with it. No, just take a picture for future reference. I'm not sure if that one, yeah, there you go. Alright, Tammy, turn it on for a moment, please. Okay guys, so what do you see? We went and we added that second channel, correct? Well, channel number 1 we put online. Channel number 2 is our current of all the cylinders of the corresponding amp reading of the primary voltage. The only coil we have back probed is coil number 6. Therefore, we know that that is number 6. This is cylinder number 6 event. How can I tell the rest of these events? How do I know what cylinders they are? That's where we need the firing order. I'm hoping this is showing up on the screen, but I drew up this little schematic thing beforehand. But the firing order is 1, 4, 2, 5, 3, and 6. Since I have 6 back probed, we're going to see its voltage reading, right? The other ones, we're going to just simply see all the corresponding amp readings, but we'll be able to point out number 6. So after 6, the cycle starts again. So next in line, so it goes 6. Next one will be number 1, and then number 4. And what do we see, guys? Right there's our confirmation that there is indeed an issue in cylinder number 4. But what is the issue? I'm going to zoom in on this capture we have here, because I want to show you how Ford uses this multi-strike setup. This is at idle. If I bring it above idle, it will eventually go into a single strike. But you can see the coil is turning on. This is at 40 volts per division. So you see that little yellow number 1? That's your 0 volt line. A little ways up from that is probably your running voltage, and we could take a measurement of this. And that's telling me that that's probably right around 13 volts. And then you see when it pulls down to ground, that coil is turning on, and that is your dwell time, okay? That is your dwell. Coil's charging. If I zoom in a little bit further, you will see some oscillation taking place, okay? As that thing is charging, you're seeing that oscillation in that ramp. That's a good sign. I learned a lot of this stuff by watching our friend Scanner Danner, and I take notes. And I tell you guys, I learn something new every day, and I watch and I learn, and that's why I try to share as well. So it's charging something on that secondary side. It's not saying that it's perfect, but there's something taking place over there. If it's nice and smooth, then it's not charging anything. So, and I learn something new every time I look at these waveforms, and that's why I want to share this one with you, because I want to know what your guys' perspective is of these waveforms. So as we got here, we'll call this a known good. Number 6 has a brand new coil, brand new plug. Everything is gapped to spec. Okay, so the coil's turning on. There's your dwell time. You see the spike when the coil turns off. That's because of the magnetic field collapsing, just like you'll see in the fuel injector, current ramp, and voltage as well. Drops off nice and sharp. The multi-strike system takes over again, so you're not seeing a good burn time because it's being interrupted, and then it starts charging again. Burn time starts, you can see right here, but it's interrupted. So when you want to measure your burn time, you would do it down here, I would assume, because this is your nice clean burn time. If you want to measure your good current ramp, I would measure it from this side. Same thing with your dwell. Measure your dwell from here, measure your burn time from here. And we can take these measurements. So if we go down a little bit, we know, looking at our notes, we know if that's number 6, next in line will be number 1. Number 1 looks very similar to number 6. We're not seeing the voltage side of the primary because we don't have that one back probe. So after number 1 becomes number 4. After number 1 comes number 4. And this is where it gets interesting. Bam. What is going on there? I would like to know. I would like to take a picture of that too. Okay. That is the misfire on cylinder number 4. Now I'm going to take you back and we're going to look at number 1, and we're going to take a picture of that. That way I could put these side by side for you. What the heck, guys? I'm going to do a quick save because I'm not sure if that does just that portion. I think it does. I'm not sure, but we'll find out. I'm going to do a quick save of this too. Hopefully I can put them over top of each other. And this is a nice one here. Quick save. More. Can you tell me what kind of misfire that is? And is it a coil? Is it a spark plug? Is it voltage? Is it ground? What is it that's causing that event? Zoom in a little bit more. That's something else, right? I honestly don't know what's going on inside that coil, but maybe one of you guys know more about this than I do. One thing I'm curious to see, now that we have this out of the way, is what does, since we could get to it on this one, and if we really had to, we could get to the primary voltage of number 1 as well. We just have to locate it in a different location. However, I wonder what the primary voltage looks like compared to the primary voltage on number 6. Would you guys like to see that real quick? What I'm going to do now is simply move the back probe from number 6. We're going to back probe number 4 coil. Put this back to 20 milliseconds again. just to make sure everything is still good. Tammy, can you start it up for us, please? Okay. So everything is just the way we left it. All right. The only difference is going to be is that the signal is now going to be in relation to the same coil with the misfire. All right, turn it off, Tam. Clean slate. This is with channel number 1 now on coil number 4. Let's see what we got. All right, Tammy, start your engine. Must have back connection. That better? It's got a pretty good misfire at the moment. Actually off the scale. The misfire when I'm back probing ignition coil number 4 is really interfering with the microphone, as you can hear. So we chose to do a quick voiceover. I'm going to turn off channel number 2. That way we could just get a closer look at the primary voltage and see if we could get some more detail, because this will tell us a much greater story. So I'm going to zoom in a little bit, setting my trigger. It's showing us a lot more detail, and we're going to take a closer look at that and compare it to the other good cylinder. I want to take a picture of this at 1 millisecond. Okay. We're going to start this, and I want to get the same capture on number 6. Okay. Here's number 6. Now we're good. 1 millisecond. Throw channel 2 back in the equation. So here's my question to you guys. Click on the reference. Reference 1. I'm going to go to the very last capture. Okay. That's our known bad. Okay. Reference number 2. I'm going to put a known good. I'm also going to turn off channel 1, channel 2. And we're just going to look at these two signals that were captured on the same time base, but from 2 different coils. This is the primary voltage. You see there's an evident difference between the two. What is causing that to happen? Is it a coil? Is it a plug? Is it a wire? Is it a boot? Is it a gap? That's my question. Zoom this in for you. We could do the same thing. The good one. We don't even have to really measure it. As I could tell you, the dwell time. Okay, this is your dwell. A little higher voltage spike. On the misfiring one. You can see an evident difference in what would be the spark line. But then the computer, of course, is cutting that one short. Same thing. And then the good spark line of the good cylinder, you can see, is much longer. There's actually a spark line there. Okay. Let's turn off reference number 2 for now. Okay. So now we're looking at the known bad. Okay. Cylinder number 4. Let's bring up some cursors. We're going to get this one as close as we can to 0. You can see that taking place up here. So Y1 is at 0. These fine adjustments get you in really close. Y2, we're going to try to bring up to the very tip of our highest reading. And that is our power kV. We are hitting a total of 173.6 volts. You can see that indicated there. Let's go back to our reference scale. We're going to turn off trace number 1, and we're going to turn on number 2. Okay. $156.8, right around there, give or take. 156.8 volts, number 6 with no miss. Go back. So now I'm going to take a reading of the time. Okay. Now we're on cylinder number 4 with the misfire. We have a total of 1.78 dwell. That's milliseconds. No measurable burn time that I could see. Pretty close to the same. On cylinder number 6. So the last one was cylinder number 4 with the misfire. Cylinder number 6, you can see it's right on the money. So I would say 1.78. Now in this one, I can actually measure the burn time. I'd put it right around there. I have a total of 1.18 milliseconds. You see the burn line that I'm talking about now? There really isn't one to measure. And if we do consider that, that is 180 microseconds. Really nothing to speak of. I'm going to let you guys tear that capture apart and fill me in, educate me please. Okay, and here's probably 2 of my cleanest captures of a known good. Cylinder number 6, current, and a misfire, a slight misfire on cylinder number 4, current capture as well on the same time base. So is that telling you enough right there to make a call on a certain component? If I were to just slap the clamp on and we were dealing with a coil that's underneath the intake manifold and we were triggering off of another coil that was easy to get to, is there enough here in that capture to say, I got to remove that coil or plug and start digging deeper. I know what corrects it, and now on the next video we'll fix it by replacing those or the component. But it would be cool to know exactly what is going on. I know the what, I just don't know the why. And I see this a lot in waveforms, that it's known bad. Okay, there's something definitely going on there, but why? That's like next level stuff. And that's where I want to take you guys with me in this learning process that I'm trying to go through. That puts it in a little greater perspective. R2, misfire, cylinder number 4. R1, no misfire, cylinder number 6. Look at the freaking downward spike on that one, man. Let's turn up R1. Way down here, and how does that happen? Peak to peak, we hit 13.56 amps. .24 on the first initial, and then the second two about 4.28 amps. .32, I would say, on that last one, had a little higher peak. Okay, so I'm going to leave you with this capture. Tell me what you think. Hopefully I didn't bore you guys too much and you find this interesting as well as I do. And hope you enjoy learning with me, and I hope to learn from you guys. So if you know any more about this waveform, what exactly is causing this, same thing with the primary voltage, what's causing that to happen, let me know in the comments below. Thanks for watching, guys. Stay tuned, and we'll do a follow-up video on this.